today's session. And I would like to gratefully acknowledge that Science World is located on the traditional unceded territories of the Musqueam, Squamish, and Tsleil-Waututh peoples, whose stewardship have been stewarding land for millennia and who continue that today. So I'd like to thank them for that. And I will just let our mentors introduce themselves. So please do hop in, tell us your name, tell us what you do for work, and maybe just something that you really love about your job. Let's start with Bambi.
Hi, I'm Bambi Brewer. I'm calling in from Pittsburgh, Pennsylvania. This is Lucky, who decided that he had to join us. I'm the head of customer experience for a company called Agility Robotics that makes large walking robots. So I'm kind of in charge of training people how to use those, making them easier for people to use. And let's see, I've only been at this job for about a month, so it's kind of hard to choose my favorite thing since it is new one. So I'll pick an easy one, which is that we get free lunch on Tuesdays and Thursdays. The robot is really cool too.
Yeah,
that sounds very cool. Well, hi everybody, welcome. I'm so glad that all of you are here. My name is Kelsey Derringer and I'm the co-founder of Codejoy. We're an online robotics education company, so we teach kids how to code, and their code actually controls our robots live during our broadcasts. So I co-founded this company with someone that I used to work with. Actually, when I used to work with Bambi and I worked together for about 3 years. And I think one of my favorite things that we do is designing new robots. So like this little guy here is one that I like a lot. He's really cute. His name is Walter. And he's like just a kind of grumpy little old robot. And I just like him a lot. So I love designing and making new and creative robots.
Awesome. Hi, my name is Lana. I am currently located in Vancouver, British Columbia, as I'm sure some of you are as well. I work at a company called Zebra Technologies, and we make motion control products. So things that spin, things that go in a line, things that move in teeny tiny increments, much smaller than a human hair. And I have been on the designing of those products side, and I am now working more on the making those products for our customers side on the production team. And the thing I like most about my job is that I get to work with a lot of very interesting people and dogs. We have a lot of dogs in my office. And yeah, if you're having a tough day, you can actually go around the office with treats and you can kind of pet the dogs for a few minutes and, check in with the dog people as well. And it's a great way of reducing stress, but also getting an opportunity to meet and talk to your colleagues. So yeah, that's
Great.
Lunches, dogs, it all sounds awesome. So for anyone who's just joining, if you've got any questions you'd like to ask our mentors, please do pop them into the chat. But I'll kick it off with just a little bit of background information. What got you started into this career? Let's start with Bambi.
So I have always loved math for pretty much as long as I can remember, but particularly once I got into algebra and things in junior high and high school, where I thought it got a lot more interesting. I really liked calculus. So when I went to college, I studied math and physics. And I finished college and I realized I did not really know what I was going to do with those math and physics degrees. And so I decided to go to graduate school, which is incidentally not a great reason to decide to go to graduate school, though it worked out well for me. But I knew by then that I wasn't particularly interested in theoretical math and physics. I really wanted something that was more applied. And so I applied for graduate school in robotics and worked in robotics for stroke rehabilitation. So working with people after strokes or traumatic brain injuries to try and exercise their hands to help them recover. And when I finished graduate school, I was a professor for a while, and there were a lot of things that I really enjoyed, the teaching part. But after about 6 years, I decided that I wanted to make a change, and I went into educational robotics because I had been working with students in rehabilitation science, and I kind of wanted to know, they didn't necessarily have some of the math and science skills that I expected, and so I was interested in seeing how that could be improved. And what am doing now is kind of a continuation. So educational robotics is one of the only places where people who are not robotics experts have been using robots out in the world. And so what I'm really interested in is making it easy for anyone to use robots. That's something that I find really exciting. And so it was great to do that for kids and teachers. And now I'm going to do that for a different group of people.
Amazing. That's so fun. I love that, sort of bringing it more into the mainstream than you might expect. That's a very cool thing to do. Kelsey, tell us a little bit about yourself and your background.
Yeah, I've always found Bambi's background just incredibly inspiring. How she like saw a problem, she was like, "All right, we need to go back to kindergarten to fix this." And I think that really kind of resonates with me too. So my background was not in robotics or math or science at all. I went to school to become an English teacher, and I did. I was a middle school English teacher, and then when I moved to Pittsburgh, where I am now, I started teaching this after-school girls-only STEM program. Hey girls, what's up? I really love teaching girls. And I got into it because I just, I loved the age group. It was 4th and 5th grade. And I was just really into working with that population, not having really much of a STEM background myself. But we did some robotics. And at first, my girls were really kind of hesitant about it. They had some ideas about what it was going to be like and how it maybe wasn't for them. But then as we actually got into the projects, they loved it. And they extended it. And instead of a 2-week project, it turned into a 6-week project. And they ended up really being engaged. And I was fascinated by that, how this one thing could just completely change their mind, how this one hands-on project could do that. So that got me really into robotics. So my first experience programming a robot was my boss said, "Hey, by the way, you're teaching robotics next week." And I said, I don't know how to do that. I'm the teacher who is really good at like the feelings rock and making sure everyone got an extra snack to take home. Like that was my teacher jam. And so that first year, I really learned right along with my students. But it was really their engagement and their interest that drove me. And, that led me to working at my last company and teaching teachers robotics. And I really emphasized teaching teachers who maybe weren't going to be computer science teachers. These were like middle school English teachers or librarians or after school teachers, folks who didn't know what computer science was before we started, but by the end of the day had a robot that they had designed and made and were proud of and were ready to go bring that to their kids. And so my company now, we teach both kids and teachers. But really how I got into this was through following the interests of my students. I always knew I wanted to teach, and seeing how interesting robotics was, that's what got me into it, their joy and their desire to learn more. And then I've just let my own interests kind of follow me through there of teaching teachers and then getting more into kids and using my theater minor. And, so I majored in English teaching and I minored in literacy education and theater. And I've learned everything I've known about robotics along the way, learning from amazing mentors like Bambi and others. And the teachers that I've taught have taught me a lot. So my pathway is very non-traditional in that respect.
Awesome. Would you say that having a bit of a non-traditional pathway, has that been a bit of an advantage? Has there been any sort of like bumps along the way because of it?
Yeah, I think it's really been an advantage in a lot of ways because I spent a lot of time, in theater and, I've been dancing since I was 3. So a bunch of stuff that I spent time on that wasn't school related really at all has really benefited me because what I do is I present about robotics now. So I need to be able to explain it to people who might come into the session a little bit like, this is going to be too hard. I don't think this is for me. And I need to get them by the end of it to say, this is exciting. Right. So like, it's been a real boon, a real plus, but also I've definitely, met people at conferences and things where like I said a word incorrectly. I put the emphasis on the wrong syllable once. And so like, there's a type of data called Boolean data and I called it Boolean data once and like someone like laughed at me and I was like, oh no, okay, I'll leave and never come back. I was just like so embarrassed. And so, there's little things like that, but just having amazing people who see the value that you bring to a space, even when it's a non-traditional value, say like, never mind those people. Like, you brought something. You're here for you. Learn how to say that word and let's move on. You know, that was always really, it's great to have people who will encourage you whenever those things come up.
Absolutely. So crucial. Lana, let's hear about you.
Okay, so when I was in high school, I decided I was going to be a doctor, and that was my career path. That's what I started with in university. I went through biology. I learned all about cells and genetics, and I, was traveling in that direction. And then at some point, it occurred to me that that might not actually happen. Like I might not get there. My grades weren't perfect. There were other obstacles in the way, and I started thinking about what I also liked. I've been laser focused for years on this idea of like the one career path that was going to make me happy, and I realized that all this time I'd been in university, I'd been watching friends of mine who were doing all these really cool projects, like hands-on building cool machines and stuff. And I was watching them. And I was so jealous. And I kept thinking that that was something that I just couldn't quite, it was just out of reach, something I couldn't do. And then my roommate, actually, somebody I'd been living with for 3 years through university. We were best friends and close roommates. She abruptly transferred from biology as well into computer engineering, and she just left me. And I thought, wow, okay, so she has the guts to do it. And the two of us, I would say, were probably two of the worst people in math in first year. We were the only two who didn't have any exposure to university math from our high schools because we came from very small towns. So the two of us were probably the least equipped people of our cohort of biology students to actually transfer into engineering. But she did it, and she was good at it. And so a year later, I transferred too. And I got into my first choice program, and I kind of went through it, and I kept having this thought in my head that, I'm doing this, but am I really here? And I kept kind of having to tell myself, yeah, I can keep doing this. And each year that I got the grades and made it through the program, it kind of started to reinforce that idea that maybe that was something that was accessible and it was fun. And I still wanted to go in the medical route when I was going through school. So I took jobs that were medical device inclined, and I took extra bio kind of medicine related classes. And then when I graduated, the job market had fallen through, and I got a contract job doing biomedical engineering, but it wasn't a full-time position. And I was looking for other work, and a friend of mine, a programmer actually, introduced me to a friend of theirs who had a startup company that happened to be Sabre Technologies. That's where I work now. So that was about 12 and a half years ago or so. And I joined the company, and I learned a lot of what I needed to do to learn about programming, about robotics, about designing mechanical devices here on the job. So for me, every step of my journey has been kind of figuring out what I need to learn, and then convincing myself that I could, and then doing it, and then, kind of taking that next step. So I think I got a lot of exposure to things a little bit later in life, but if there's any lesson in that, it's that you're not too late to go down a path. Just because you haven't learned something yet doesn't mean you can't. So.
And I think that's really like, I see a lot of people, and I hear my son is in high school now, and I hear other people his age worried that they don't know what they want to do. And I think, like, you could argue I didn't figure it out until my mid to late 30s. So there's definitely, like, I don't see how anyone could possibly know what they want to do at 18, but it's 100% not, like, it's not a problem if you don't know exactly what you want to do. There's plenty of time to try some things out.
Yeah, you have not missed the boat just because somebody else already knows how to do something and you don't yet. Like,
and I love that you're like Velcro onto something new. The thing that drew you into something new was they're doing fun stuff over there.
really
I
cool.
want to do fun stuff,
Yeah.
right? So I think that's just such a powerful skill to build, which is to go up to someone and ask if you can play.
Mhm.
Like, can I sit and watch? Can you show me how to do that? And like 9 times out of 10, they'll say like, oh yeah, they would love to show you what they're doing. And that 10th person, don't play with them. They're not nice. Go find somebody else, right? But like just finding cool projects online or that your friends are doing or other things out there. And even if it has nothing to do with your major, like that's how I got involved in a bunch of really cool theater stuff in college, which really taught me how to write a show. And now that's what I do. I write interactive shows. Like we were doing devised theater stuff. Had nothing to do with my major, but I was like, those people look like they're having so much fun. I want to go do that. And I'm so glad that I did. And I wouldn't, I think that skill that you learn when you're 5, which is going up to someone and saying, play, like that is a life skill. And I think sometimes we forget that, or we think we're going to get laughed out of that conversation, or we think someone's going to be like, no.
Yeah.
Don't play with that person. But everybody else, almost everybody else would love to invite you in, So just like noticing what's interesting to you and going and doing some of that,
Absolutely. In addition to, sort of the skill of just asking questions and being curious, what other skills would you say, and I'll just open it up to the panel, would you say are important to focus on if you're thinking about getting into robotics?
I think a good general, certainly a pretty broad background, I think, is helpful. It is completely untrue that robotics people never need to write anything. I do write quite frequently. I really find that math is a great one to have a good background in part because if you know enough math, you can cover deficiencies in any number of other skills and it will be fine. I didn't have all the other people in grad school were engineers or computer scientists, but I was enough ahead in math to buy me some time to catch up in some other things while other people were doing the math part. So there are definitely opportunities to pick up other skills along the way. But I think kind of having, for me, a broad background has been helpful.
Yeah, I think one of the things that I learned at my last company that I was at was I learned about this term of computational thinking. I didn't know what it was before then. Computational thinking, I was like, oh, okay, thinking like a computer. That seems impossible. I'm a person. What it actually is it's a problem-solving method. I bet a lot of us have heard of the engineering design process. That is a way to approach a problem in an iterative way where you try it, you think of a solution, you try it out, you test it, you learn what went wrong, you ask a new question, you come up with a solution. That's one way of solving a problem, and I'm so glad that I had a bit of a background in that. Computational thinking is just another way to solve a problem, and it's kind of like solving a problem in the way that a computer might do it. So things like a concept like decomposition, which is where you take a big problem and you break it down into a bunch of smaller problems. And when you've solved this one and this one and this one, lo and behold, you've solved the whole thing. I hadn't heard of words like decomposition or modularity or modeling. I thought modeling was something that Tyra Banks did. No, modeling is when you take 2 pieces of cardboard and you hold them up next to each other and you say, oh, this is how the joint is going to work. I need to put the motor here. That's modeling. I didn't know about some of those terms. And when I started learning those and I started teaching teachers about them, I started seeing those problem-solving skills in my own process, ways that I could make those things better. So just learning about some of the skills within computational thinking made me a better coder and a better programmer and a better inventor and designer because I knew different ways to approach a problem that would really jive well with how my robot, the way that the programming language worked to control the robot. So computational thinking, looking into some of those skills.
And I would recommend taking things apart. That's something my brother and I did. We didn't have a lot of stuff. We didn't have a lot of TV. I grew up on a farm, and we were so far out of town, we didn't have cable. But we took apart things a lot. We took apart electronics. We took apart, motorcycles and other bits and pieces. We took apart toys as well. And when you take apart things and you see how they fit together and you see how the various parts look, you can start to make some guesses about how they actually function. If you've ever taken apart a motor, for example, there's a lot of really cool, interesting technology in there that's meant to do stuff. Whether it's bearings that support a motor shaft, or whether it's a little washer in there that allows the motor to physically expand when it gets hot without breaking apart. You can, when you start to take apart things, you can start to see commonalities too. Things that, there's a standard way that someone might make a thing work, or might make a wheel go around. So I would totally recommend finding something and taking it apart. Make sure your parents are okay with it. But,
Yeah, and even extending that to like code, I really appreciated whenever I found some code that worked, that did something that I wanted it to do. And then I would go back and reverse engineer it. I'd go in and I just like change one number and then watch how that changed something. And I'd be like, oh, now I know what that distance sensor threshold is doing now that I changed it. So like going in and taking code apart, or like I remember there was some project we were working on. I think I was working on a hand, like a prototype, an earlier version of this hand thing here, when Bambi and I worked together at Bird Brain. And there was some radio code that she had built. And just finding someone who's willing to let you argue with them and let you be wrong. Like I remember being like, that's not how it works, Bambi. And you're like, yes, it does. Look, it's working. And I was like, but what if I did it this way? You're like, it'll be broken, but you can try it. And like, you were so patient. Finding somebody who can let you argue with them and let you pick apart that code, and like, just, sometimes you can find someone to ask. Sometimes you can ask the code and just change something and be like, okay, oh, that's what that does. I changed it. That's what that number does. So taking apart stuff and taking apart somebody else's work that they can even talk to you about. That's really cool and fun.
Yeah, for sure.
That's very cool. So I'm curious, what is something that is really cool about your job that maybe you didn't expect when you first got into it, and maybe something that a lot of folks don't know about? Bambi, I'll throw it over to you.
Okay. Well, I've been in my new job, like I said, only about a month. But in general, one of the things that in working with people who work with robots that I find fascinating is we as engineers think we know how somebody is going to use something. And I love like the first time you give it to somebody who's actually going to use it, because it is never what I thought they would do, and very often is as far as possible from what I thought they would do. And I just find that fascinating to see how different people take the same object, but you don't necessarily see the same thing or think that it's going to work the same way. And so that's something that I really love, is when you can take things out of the design phase and take them to people to try, even like very early prototypes, to start to see like how people react to it and how they use it.
It's very cool. It's in their own way, they're kind of learning a little bit by destruction as well. Like they're sort of probably breaking things a little bit and using them in unexpected ways, which, I bet that would be really fascinating. Kelsey, what about you?
Yeah, I think so in what we do as Codejoy, we're not just doing robotics, we're doing robotics in a way that we're trying to make it maximally accessible to other people. So my co-founder, Matt Chilbert, he's amazing at a particular kind of design, and I've learned so much from him. He and I have been working together for about 5 years now, and I'll show you a couple examples of what I mean. So like I'd showed you this little Walter robot here before, this like cute little guy, and something that Matt wanted to do was to take this robot, which is made out of 2 like 3x3 boxes and a couple of position servo motors up in the head, and he wanted to make it out of even simpler materials, random stuff. So he made this cup bot, and I'm going to take its head apart. Don't worry, she'll be fine. I'll put her back together. Her name's Kiki, by the way. But Kiki, she also has a motor. It's just sunk into a cup. And so it's like, what are the essential elements of this thing? And how do we, and so the head is just a flat piece of cardboard that we like go in here. This is a little robot for a show called Robot Relaxation, where the robots have test anxiety and they're really nervous. And so we've got to like calm them down by creating some animations. It's really cute. But like, you know, the eyes are taped, but it's just like cups and cardboard and a couple of motors. So something that I didn't know when I started getting into educational robots was the goal when we're making stuff is not to make it the best, most advanced version of whatever it is. We're thinking about how to make it the most accessible version of what it is. So like if it requires something like a 3D printer, that cuts a lot of people out. So we don't do stuff with 3D printers, you know? So like the design aesthetic of you've got to be able to find this in your garbage, put a motor on it, and be satisfied with the result. That is a way of thinking that I think a lot of folks, like there's a huge like maker movement, right? And like if you're just making something for yourself, like use everything at your disposal, take it all apart, put it back together, Frankenstein it, make something that you're proud of that's like cool and quirky. But in the educational space, making something cool and quirky just guarantees that not very many people are going to be able to do it, you know? So like I really like this aesthetic of like common supplies, craft materials, and it's a different way of thinking, kind of like computational thinking was a different way of problem solving. This is a different way to problem solve when within each of our problems, there's the constraint of you have to be able to use really regular materials to do this. And it's something that we continue to get better at. Like we'll make a robot that works and we'll be like, nope, it needs this. And not everybody's going to have that. So let's make it again to make that part more accessible. But it's something that you may not know when you look at like the design aesthetic, but that it's very consciously accessible, you know, those different materials.
Very cool.
Yeah. I think that's something that's a common thread to my working life too, is making something one time is pretty meaningless if you make something that you are selling in reasonable volumes, and you need to not just make it, but make it efficiently in a time-sensitive way, be able to ship it regularly with parts that are accessible. Our life right now is made very difficult by parts shortages of all kinds throughout the world. So one thing that I've learned about the whole engineering design process is that it's trivial to make something one time compared to making something that you can produce over and over and support and have, you know, customers know how to use. And what we really do a lot of now is iteration on designs that we considered complete to make them more manufacturable, to make something, you know, to design around a component we can't access anymore, or to cut out some expensive thing and replace it with a different version that might be just as good, might even be better, but requires additional time and effort to design around. So,
well, and I think that's something you don't always get a chance to do in school, because you always have to move on to the next unit, next thing.
You're done.
Yeah, you don't get a chance to. And so I see that in students where they're like, okay, I did it, I'm done. I'm that like I'm done syndrome. But I don't fault students for that, because like that was like pounded into all of us. Like, you must be done now. It's time. We're moving on to the next unit, right? But why would you remake something over and over again? Well, why you're doing it is you have an authentic audience. You have to remake that over and over again because somebody needs it to be a certain way. Versus like, why would you go through that design process again if the point is just to get like a grade, like to get a better grade, I guess, you know? So like, I think something that I learned as a teacher, and that I'm so grateful that I did as a kid and as a learner and as a college student, was like, I just got involved in projects that were going to be on display somewhere, or were going to be for something, whether it was like, we're going to put a play on for the neighborhood, or, you know, we're going to make this movie and show our parents, or like whatever it was. Creating an authentic audience gives you a reason to do it again, because if it's not right for your audience, well, let's tweak it and do it again. But when you're only doing things to get, like, once the grade is done, like the grade is done, right? So like I was so grateful that I had the opportunity to do some stuff outside of school where grades didn't matter, but my pride did. And my friend's pride was wrapped up in it, and we cared how it turned out. And that gave us a reason to make it right and to go through it multiple times, you know?
You had more intrinsic motivation to follow through in that way.
Yeah.
We're coming up, approaching the end of our session. But before we get there, I really am curious as well about what each of you thinks hopes will happen in the field of robotics in the next 5 or 10 years, and maybe a little bit of what you think might happen. Lana, let's start with you.
Ooh. Yeah, that's kind of tough because I don't always think of myself as in purely robotics. I'm always focused on the individual, like, moving element and the design of it. So I'm not always looking at the kind of larger picture of automation. Yeah. I'm actually really unsure. I mean, there's a lot of avenues, a lot of things that are really cool technologies coming out, you know, like automated vehicles. I am sort of looking forward to my kids not having to learn all of the rules and details of the road and having a car that can kind of keep them safer than their own brains might. But yeah, I actually have a very muddled picture of what the future looks like, because in my world, I'm just thinking about how we automate very low level things, like putting balls into a carriage that will, you know, have a recirculating ball bearing path. So, you know, I'm not thinking about the future of robots that interact with humans as much as I am about something that's very, like, focused on one little tiny aspect of my personal world. So, yeah.
Yeah. Maybe then the world is a little bit more efficient in small ways, potentially. Abby, what do you think?
So I feel like we're at a point in robotics where there've been a lot of demonstration products, people demonstrating cool things, and we're really at a tipping point of people trying to take those from a laboratory or a demonstration out into the real world, which I think is going to touch on a lot of the things that Lana and Kelsey both mentioned. Like, it's not enough for it to work once; it has to work all the time, and I think that's a really difficult thing. But I think that's the next essential step. Like, it's not enough to demonstrate that your robot can solve that problem one time, or that maybe it can do some task. Like, you wouldn't want to buy a robot that folded laundry if it only folded every other piece correctly.
I'm that good at laundry. I don't need a robot to need something more accurate than me.
So I'm really excited to see how we make these things more robust, how we make them easier for people to use. Because I think there's a lot of people who are ready to take that next step.
Very cool.
Yeah.
And Kelsey.
So this is such a cool question, because, you know, when I teach coding, the form of coding that we teach, and I'll show you right here, is block-based coding. This may look familiar to you out there, dear viewer. You may be doing some coding like this on something like Scratch or Snap, or this is Make Code right here. And the way this works is that there are these, like, little blocks that you drag out and snap into place, and they're color coded. And a lot of teachers ask me, like, okay, but, like, when do we do the real coding? And they don't see this as real coding. Well, you know, real coding to them looks like this. It looks like text. It looks like something that you type out. But something that I'm really excited to see on the horizon, we were just working with a Pittsburgh-based company that makes robotic arms with all of these very advanced cameras on it. So, like, this arm can use all these cameras to look inside of box of a bunch of very similar materials, go inside, grab one out, shake the other ones off that are clung onto it, and put it in a box. And the code that they're using, that adults are using, that their technicians are using, looks more like this. Like, block-based coding is a really easy to understand, consumer-friendly way to interact with a robot and to get it to do something that you need it to do. So, like, technicians, these are folks who don't have PhDs in robotics. These are people with maybe, like, associate's degrees in various topics. Like, these technicians are using block-based coding like this to make robots do what they need them to do. And so, like, the future of manufacturing, like, we're all going to need to learn to interact with robots. And I think that that the coding is going to get easier. The coding has already gotten easier for kids, but there's no reason that adults can't do that too. You know, those interfaces are really coming a long way in the last few years. So something I'm excited about on the future of robotics is that coding is going to continue to get easier, not just for kids, but for grownups in the jobs that they go into. So the skills that you're learning in MakeCode and Snap and all those block-based coding languages, not only are the computational thinking skills going to transfer, but like the process might actually transfer too, which is just really exciting.
Amazing. Yeah, that even that looks approachable for me, who doesn't do any coding. Much friendlier, much more like something I think I could wrap my head around. That's really exciting.
Totally. You can totally do it, Jen.
I appreciate that vote of support. Thank you all so much for spending time with us today. And I hope all of you out there enjoyed this conversation. So thanks again, and hope to see you at some other sessions.
Thank you so much. This was great.
Thanks, everyone.
Thanks for listening.